So last class we discussed about the um, performance of transmission lines, that is class of transmission lines, as well as um, short transmission lines, medium transmission lines, transmission lines. We have to determine voltage regulation, as well as efficiency, and also sending end voltage, receiving end voltage, sending end power factor, right? So all these parameters we have to find out. For short transmission line, medium, again medium, we have three methods: end condenser method, Nominal-T method, Nominal-π method, right? So after then go for the long transmission. So long transmission lines. So only one method is there, that is the rigorous method. Rigorous method of calculation of transmission line is very important. In medium transmission lines, we go for the lumped parameter calculation, whereas in long transmission lines, we go for the uniformly distributed parameters calculation. We don't go for the lumped parameter calculation long transmission lines. Why? Because some problems, some errors will be introduced in the long transmission lines when we are going to the lumped parameter calculation. That's why we don't go for the lumped parameter calculation in the long transmission lines. So we go for the uniformly distributed transmission line parameter calculation, right? Now, so those are all already we have to discussed. For calculating the voltage regulation, for calculating the transmission efficiency, sending end power factor, sending end voltage, all these things, right? Now we go for this section of second unit, that is the determine the generalized constants, that is two-port network parameters of a transmission lines. For short transmission lines, for long transmission lines, and also medium transmission lines, that is to calculate the ABCD parameters for Nominal-T method, Nominal-π method, most important, and also as usual these are the look at the slide. So rigorous method of long transmission lines. So already we discussed about the problems also, right? For long transmission line, for short transmission lines, and also end condenser method, all these things, right? Now we go for the generalized circuit constants, right? That means we have to determine the ABCD parameters for short transmission line, for medium transmission line, and long transmission. First, so generally, what is two-port network? What is single port? Single port is nothing but it will having only two leads. Coming to the two-port network, it may contains 4 terminals. So input side 2 terminals, output side 2 terminals. So in any 4-terminal network, the input voltage and input current can be expressed in terms of output voltage and output current. That means in that 4 terminals, we know the 2 parameter values, and we don't know the again 2 parameter, the remaining 2 parameters values. So by using known parameters, we have to determine the unknown parameters. So right, that is nothing but so voltage or current. Suppose voltage is known, current are unknown parameters. So current is unknown parameters is nothing but voltage is known parameters. So voltage is unknown parameters, current is known parameters, that is the Z parameters. V1 is equal to Z11 I1 plus Z12 I2, V2 equal to Z21 I1 plus Z22 I2. Similarly, currents are unknown parameters, voltages are known parameters, nothing but Y parameters. I1 is equal to Y11 V1 plus Y12 V2, I2 equal to Y21 V1 plus Y22 V2, right? So like that. So next coming to the ABCD parameters. So input parameters are unknown parameters, output parameters are known. That means V1, I1 are expressed in terms of V2, I2. V1 is equal to, so A V2 minus B I2, I1 is equal to C V2 minus D I2. That means, so this is the important for our transmission network. That means we know the input values, we don't know output values. We know the sending end values, we don't know receiving end values. Consumers దగ్గర values మనకు తెలియదు. So sending values తెలుసు కాబట్టి, so that means we go for the ABCD parameters for the transmission. That means calculation of ABCD parameters for transmission. We don't go for the Z parameters, we don't go for the Y parameters, go for the ABCD. Why? Because in ABCD parameters is nothing but input values are unknown parameters, output values are known parameters, right? So you look at the incidentally, a transmission line is a four terminal network. That is two input terminals where power enters into the network, and two output terminals where power will leave the network, right? So suppose therefore input voltage Vs, input current Is of three-phase transmission line can be expressed as Vs is equal to AVR plus BIR, Is is equal to CVR plus DIR. Vs is the sending end voltage and Is is the sending end current, VR is the receiving end voltage per phase, and IR is the receiving end current. That means ABCD parameters are the constants known as generalized circuit constants of transmission lines. So calculate the generalized constant of transmission line is nothing but calculate the ABCD parameters of a transmission line. Suppose it may be a short transmission line, or it may be a medium transmission line, or it may be a long transmission line, depending upon the length or depending upon the voltage. We classify the transmission lines short, medium or long, right? Simply say that generalized constant of transmission line, that is nothing but ABCD calculation, ABCD parameters of transmission lines, right? Once the values of these constants are known, so suppose we calculate the ABCD values, then you easily find out the Vs and Is, right? We know the VR, we know the IR. Receiving values are known parameters. So output values are known parameters. Input values are unknown parameters. That's why. So remember last classes, every method calculating the voltage regulation and sending end voltage, sending end power factor, efficiency, right? We know the receiving end voltage. Suppose you draw the phasor diagram first, take the receiving end voltage as reference, then adding the resistive drop, then adding the reactive drop, then add all the parameters factorically, then we are getting the sending end voltage Vs is equal to VR plus IRR plus ISR plus ISXL, right? So drop, resistive drop and inductive drop may add it to the receiving end voltage such that we may getting the sending end voltage. Similarly, the VR, IR is known parameters, right? These two values are known, but ABCD parameters are unknown parameters. We don't know. Suppose we have to calculate the ABCD parameters for a particular given transmission network, then easily find out the sending end and sending end voltage and current, Vs and Is, right? So just remember, generalized constant of transmission line is nothing but ABCD parameters of transmission lines, right? So mainly the following points are just you have to remember. The 4 points are, remember already we know the parameters, We have already studied the two-port network in the electrical circuit 2 or electrical circuit 1 EC1, right? We know all the things. So what is the condition for reciprocal? AD minus BC equal to 1. What is the symmetry condition? A equal to D, right? So the constant AD are the dimensionless. Why? Because V1 by V2 lekunda I1 by I2 like that. That's why A and D are dimensionless. But D is the ohms, V by I, and C is the mho or Siemens, I by V. So these constants A, B, C, D are the generalized complex numbers, and A, D does not having any unit, but B having ohm. B unit is ohm, C unit is mho or Siemens, right? For a transmission line is a symmetric transmission line, the condition is A equal to D. This is the most important. And for a transmission line is reciprocal, AD minus BC equal to 1, right? This is also most important. So these are the points you have to remember. Why? Because we shall establish the correctness of the above characteristics. A generalized circuit constant in the following discussion. That means following transmission line, that is short, medium, or long transmission lines, right? So first, determination of ABCD constants, లేదా determination of generalized constant for transmission lines, otherwise for short transmission lines. So first we go for the generalized, the determination of generalized constant for transmission lines. That is nothing but, first we know the generalized equation, right? Already stated like this. This is the generalized equations. Vs is equal to AVR plus BIR. Is is equal to CVR plus DIR. So this is easy. Why? Because already you have to done in the EC1, right? So the generalized constants of sending end and receiving voltage are Vs is equal to AVR plus BIR. Is is equal to CVR plus DIR, right? So now you have to determine these constant values, that is ABCD parameter values for short transmission line. First siding for short transmission line. In short transmission line, there is no again methods, only one method. For medium transmission line, we go for three methods: end condenser, Nominal-T, Nominal-π. Out of those three, Nominal-T, Nominal-π more important. For long, go for the rigorous calculation. Cos H, hyperbolic values you have taken, right? Cos H gamma like that. Cos H gamma L, sin H inverse gamma L like that. We have taken the values in long transmission lines. First, short transmission lines. Look at the figure. For short transmission lines, we know for the Vs and the transmission line parameters are only resistive, inductive. So do you remember, in short transmission line there is no capacitive effect? Why? Because for short transmission line the capacitive effect is negligible. That's why in transmission line, in short transmission lines, we don't consider capacitive effect. So we just consider resistive and inductive effect for calculating the ABCD parameters, and also calculating the regulation and efficiency also. Look at the figure. Vs, Is is the sending end current, and Z, R plus J XL is nothing but Z, and receiving current IR, receiving in voltage VR, right? So look at the figure. So the Is is equal to IR, right? Why? Because this is a series circuit, right? There is no any branch in between Is and IR. There is no, suppose if capacitive effect is considered for medium or long transmission lines, so we have to connect a capacitor in parallel to the load. At that time Is is not equal to IR. Is is equal to IC plus IR అవుతుంది. So but coming to the short transmission line, sending end current is equal to the receiving end current, right? So because why? Because here capacitive effect is neglected. That's why both currents are same. So Is is equal to IR, and we know the sending end from the generalized constant Vs is equal to AVR plus BIR, right? So apply KVL, right? Apply KVL first from the circuit. IS is equal to IR. Why? Because it is a series circuit. Now from the circuit, apply KVL. Sending end voltage is equal to receiving end voltage plus drop. Right? From the phasor diagram, clearly VR ని మనం రెఫరెన్స్ తీసుకుంటాం, దానికి IR R కలుపుతాం ప్లస్ IXL కలుపుతాం. R plus JXL is nothing but Z. IR common తీస్తాం. IR into R plus JXL, that is nothing but Z. So by applying the KVL, Vs from the short transmission circuit, Vs is equal to VR plus IR into Z, right? So we know the equation 1 and 2, that is the generalized constant. Vs is equal to AVR plus VIR, Is is equal to CVR plus DIR. Now compare the equation 1 and 2 with 3 and 4, right? So compare these 3, 4 equations with the generalized constants. So Vs is equal to VR plus AVR plus BIR. That means A equal to 1, B equal to Z. And compare the third equation to second equation. Is is equal to CVR. That means C is equal to 0. There is no VR term in the third equation. Plus DIR, D equal to 1. Right? So just remember. So first from the circuit, Is is equal to IR. That is taken as equation 3. Apply KVL. Vs is equal to VR plus IR into Z. Why? Because both are same. So compare these two equations into 1 and 2. That means A is equal to 1, B is equal to Z, C is equal to 0. Very important for competition exams. What are the ABCD constant values for short transmission lines? What are the ABCD constants for short transmission? A equal to D equal to 1, B equal to Z, that means impedance. So C equal to 0. Easily you have to, what is the B unit? Ohm, that means Z. So C equal to 0. A equal to D equal to 1, B is equal to Z, C is equal to 0. Very important. So sometimes they are asking 1 mark, not 2 marks. They are asking 1 mark for short transmission lines. So now, what is the symmetric condition? A equal to D. So it is hence proved. A equal to 1, D equal to 1. That's why A equal to D. That means hence it is a proved one. So short transmission line is a symmetric network. Now coming to go for the reciprocity network, right? Suppose for reciprocity network, what is the condition for ABCD constant? AD minus BC equal to 1. So substitute all the values. A equal to 1, D equal to 1. That means AD equal to 1 minus BC, B equal to Z, C equal to 0. That means 1 minus 0 is equal to 1. So now it is also satisfied. So from the two conditions, A is equal to D, that is satisfied for short transmission lines. AD minus BC equal to 1, that is also satisfied for short transmission lines. That means the short transmission lines is symmetric as well as reciprocity. So both conditions are satisfied. That's why short transmission line is a symmetrical network as well as reciprocal network. That is the conclusion, right? Suppose they don't ask for 10 marks. Suppose they are asking 5 marks. Just draw the diagram, right? After then, write the condition, that is sending end current equal to receiving end current. After then, apply KVL. Vs is equal to VR plus IR into Z. So now these two equations is compared to the generalized constants of transmission line, that is Vs is equal to AVR plus VIR, Is is equal to CVR plus DIR. By comparing that generalized constant equations to these two equations, then we are getting the ABCD values. A equal to 1, D equal to 1, B equal to Z, C equal to 0. Applying both conditions, that is reciprocity condition and symmetric condition, both are satisfied. That's why take the on conclusion, that is, so for the above conditions, the short transmission line is both symmetric and reciprocal network, right? So this is the ABCD parameters, determination of ABCD parameters for short transmission lines. Most important for 1 mark competition exams. Suppose in our exam point of view, suppose they are asking this one, they give 5 marks, right? Now go for the medium transmission lines, right? Medium transmission lines, end condenser method is available, Nominal-T method is available, Nominal-π method is available. But For calculating the ABCD parameters, we go for just nominal-T and nominal-π. For calculating the voltage regulation and efficiency, three methods are available: end condenser, nominal-T, nominal-π. Right? But calculation of ABCD, go for the nominal-T and nominal. Very important for our exam point of view. Very important. They are asking derivation or they are asking problem, whatever it may be. So determination of generalized constant or determination of ABCD parameters for medium transmission line is very important for our JNT examination point of view. So now for short transmission line, look at the figure, ma. For short transmission line, there is no capacitive effect. That's why there is no capacity added to at the load side. But medium transmission line, capacitive effect is there. Capacitive effect is there, right? So that's why where it is connected generally load side. But for end condenser method, you have to connect it load side for calculated voltage regulation and transmission efficiency. But coming to the nominal T method is nothing but so capacitor is connected middle of the transmission line, that may divide the network into two halves. Capacitor mano middle lo transmission line middle lo connect chestam, receiving end side kaadu, sending end side kaadu, middle lo connect cheyadam valla transmission line అనేది రెండు భాగాలుగా విడిపోతుంది. దట్ మీన్స్ సో ఇందాక ఏంటి ట్రాన్స్మిషన్ లైన్ ఇంపిడెన్స్ ఏంటి Z మాత్రమే. ఇప్పుడు ఈ మధ్యలో కనెక్ట్ చేసాం కాబట్టి Z/2 దట్ ఈస్ RL/2 XL/2 RL/2 XL/2 that is nothing but IS Z/2 IR, right? But before short transmission line sending end current is equal to receiving IS is equal to IR, but here not equal. IS is equal to IC plus IR, right? So right, as usual, write the equations. KVL equations. Here two loops is available, right? Two loops are available, right? So Vs is equal to V1 plus IS into Z/2. That is the one equation. Vs is equal to V1 plus IS into Z/2. Now coming apply the KVL for second loop. So here V1 is the sending end voltage, right? V1 is equal to VR plus IR into Z/2, right? Remember? So suppose apply the KVL for loop 1 and loop 2 separately. Loop 1 Vs is the sending end voltage. For loop 2 V1 is the sending end voltage, right? For loop 1 Vs is the sending end voltage, V1 is the receiving end voltage. That's why Vs is equal to V1 plus IS into Z/2. Whereas in second loop V1 is equal to VR plus IR into Z/2. But what about current? From the diagram, IS is equal to IC plus IR, right? Therefore, IC is equal to IS minus IR, right? Ma understand avutunda? Neat ga endandi, very important. So apply KVL for loop 1, apply KVL for loop 2, and take the nodal equations. So IS is equal to IC plus IR, therefore IC is equal to IS minus IR, right? Right. So now the sending shunt admittance Y is equal to V1 into Y. So Y into, we know the V1 value, VR plus IR/2 Z, right? Therefore IS is equal to, so what is the equation? IR plus Y into VR plus Y into IR Z. But generally IS is equal to IR plus IC. IC is nothing but capacitor current is equal to V1Y, and the value is like the V1 is nothing but value. Now sending end current is equal to IR plus IC, right? Instead of IC, substitute this value. This is the IC. Capacitor current is equal to V1 into Y, but V1 is VR plus IR into Z/2. Now substitute IS is equal to IR plus Y into VR plus Y into IR Z/2. Y into VR plus, take IR is common factor, 1 plus Y bar Z bar by 2. Now substituting the V1 value in equation 5, right? Substituting the V1 value in equation 5. Equation 5, this is the equation 6, right? So this is equation 5. Substitute that V1 value in this equation. Vs is equal to V1 plus Is into Z by 2, right? So Vs is equal to Vr plus Ir Z by 2 plus Is Z by 2. Now substituting the Is value also. This is the Is value. So after substituting the Is value and taking common factor as Vr and Ir, Vs is equal to 1 plus Yz by 2 Vr plus Z plus Yz by 4 Ir, right? Comparing the equations, so this is the sixth equation and this is the seventh equation, right? Compare the sixth and seventh. So Is is the sixth equation, Vs is the seventh equation. Now comparing these two equations with 1 and 2 generalized constant, A is equal to D is equal to 1 plus Yz by 2, B is equal to Z into 1 plus Yz by 4, C is equal to Y. So this is also important for gate point of view. They asking identify the ABCD parameter values for medium transmission line for T network, right? That means A is equal to D is equal to 1 plus Yz by 2, B is equal to Z into 1 plus Yz by 4, C is equal to Y. గుర్తుండిపోవాలి అంతే మనకు. ఈ గుర్తుంటేనే మీరు ప్రాబ్లమ్స్ కూడా ఈజీగా చేస్తారు. A is equal to D is equal to 1 plus Yz by 2, B is equal to Z into 1 plus Yz by 4, C is equal to Y, right? So now that two conditions AD minus BC equal to 1, AD that means 1 plus Yz by 2, 1 plus Yz by 2, that is 1 plus Yz by 2 square minus Z into 1 plus Yz by 4 into Y. So 1 plus Y square Z square by 4, that is A plus B whole square. A square that means 1, B square, Y square Z square by 4 plus 2YZ, right? 2 cancel, that means YZ is coming, minus ZY, రెండు multiply చేస్తున్నాం ZY plus Z square Y square by 4. So Z square Y square by 4, ZY cancel, that is 1. That means medium transmission line for T network also reciprocal network. As usual, it is symmetric. Yes, it is symmetric. A is equal to D is equal to 1 plus Yz by 2, right? For short transmission line, both conditions are satisfied. Reciprocity and symmetric conditions both are satisfied. For medium transmission line, for T network, it is also satisfied, right? So like that, you have to determine. This derivation is important for 5 marks or 10 marks. Problem also important for 5 marks or 10 marks. Very, very important. Just you have to observe the network. For medium transmission lines, a capacitor is connected middle of the transmission line that may divide the circuit into two halves. That means the impedance may be divided into two, Z by 2, Z by 2. Z by 2 is one side, sending end side, another side is receiving end side, right? So two loops is there. Apply KVL for loop 1, apply KVL for loop 2. For loop 1, Vs is equal to V1 plus Is into Z by 2. For loop 2, V1 is equal to Vr plus Ir into Z by 2, right? After then, capacitive current IC is equal to Is minus IR, right? ఇక్కడ మొత్తం 3 కరెంట్స్ ఉన్నాయి. ఒకటి సెండింగ్ ఎండ్ కరెంటు, ఒకటి రిసీవింగ్ ఎండ్ కరెంటు, ఒకటి వచ్చేసి కెపాసిటివ్ కరెంటు. కెపాసిటివ్ కరెంట్ కనుక్కోవాలంటే ఆ రెండింటిని తీసేస్తే సరిపోతుంది. డిఫరెన్స్ బిట్వీన్ సెండింగ్ అండ్ రిసీవింగ్ కరెంట్ ఈజ్ నథింగ్ బట్ కెపాసిటివ్ కరెంట్. సో నౌ వాట్ ఈస్ ద కెపాసిటివ్ కరెంట్ ఈజ్ నథింగ్ బట్ ఇన్ టర్మ్స్ ఆఫ్ అడ్మిటెన్స్ V1 into Y. Why? Because the voltage at capacitor is V1. V1 into Y is nothing but capacitive current. What is V1? Already we have to determine. V1 is equal to Vr IR into Z by 2. Substitute that one. So now Is is coming, taken as equation 6. Now go for the Vs. From the equation, substitute V1 value, then substitute Is value, common factor. That is equation 7. Now compare 6 and 7, 1 and 2. A is equal to D is equal to 1 plus Yz by 2. B is equal to Z into 1 plus Yz by 4. C is equal to Y, right? So this is the ABCD constants for Nominal-T method, right? Now go for the Nominal-π method. After completion of Nominal-π method, I just finished this class. Why? Because 11:45 I have another class, right? So next class we discuss for ABCD parameters and also ABCD parameters of long transmission lines also discussed, right? Go for the medium lines, Nominal-π method. So that means for Nominal-T method, generally medium transmission is nothing but capacitive effect is there. capacitive effect is available that may be connected middle of the line that gives to the nominal T. Now capacitor is divided into half that may be connected. One half is connected to sending end, another half is connected to the receiving. ఇక్కడ ట్రాన్స్మిషన్ లైన్ ని మనం ఆఫ్ చేయటం లేదు, కెపాసిటివ్ ని 2 హాఫ్స్ చేస్తున్నాం, ఒకటి సెండింగ్ ఎండ్ సైడ్ ఇంకోటి రిసీవింగ్ ఎండ్ సైడ్. ద కెపాసిటర్ is connected at both halves, that is at sending end and receiving end side, that is nothing but capacitor is half. That in this method line to neutral capacitor is divided into 2 halves. Capacitor is divided line to neutral, right? One half is being connected to the load end, another half is being connected to the sending end, is shown in the figure, right? So now ikkada meer main figure mukyam, endukante mana equation rayali, aa equations raasta ayipoyindi ante, em ledhu, compare chestam avutoti. So Z is equal to, as usual, Z is equal to R plus JXL series impedance for phase, and what is the Y value? That is J omega C shunt admittance. Now here what is the sending end current? Sending end current is equal to IL plus IC by 2, not IC1. IS is equal to, so ikkada vache current ikkada divide avutundi, IS is equal to IC by 2 plus IL, right? Now IS is equal to, so IC2, so that is IL plus IC2 is nothing but charging current. Charging current is nothing but Y by 2 into Vs, Y by 2 into Vs. So taken as equation 3. Now IL is equal to IR plus ICY, that is IR plus VR into Y by 2. Now sending end, apply the loop. Vs is equal to VR plus ILZ. Look at the figure. Vs is equal to VR plus IR into Z, only one Z. So but VR plus IL means we know the value above, IR plus VR Y by 2 into Z. Therefore Vs is equal to, taken VR as common factor, VR into 1 plus YZ by 2 plus IR into Z, taken as equation 10. Now coming to the, we know the sending end current, IS is equal to IL plus Vs into Y by 2, but what is the Vs value? This one. Substitute 10th equation into this one and we are getting the values. Substitute the Vs value in 10th equation, we are getting the value, and rearranging, separate IR VR, so IR into 1 plus YZ by 2, VR into Y into 1 plus YZ by 4. This is 11th. Now that equation 11 and equation 10. 10 and 11 compared to the equation 1 and 2. That means A is equal to D is equal to 1 plus YZ by 2. B is equal to Z. C is equal to Y into 1 plus YZ by 4. So after calculating the ABCD parameters of T network and pi network, right? Just you have to observe A equal to D equal to 1 plus YZ by 2. రెండింటికి కూడా same. A equal to D equal to 1 plus YZ by 2. If it is a medium transmission line T network or it is a medium transmission line pi network, A, D are same. A equal to D equal to 1 plus YZ by 2. గుర్తుపెట్టుకోవాలి అంతే మీరు, ఎందుకంటే కాంపిటీషన్ ఎగ్జామ్స్లో, గేట్ ఎగ్జామ్స్లో డైరెక్ట్గా వాడు డైరెక్ట్ ఫార్ములాస్ అని ఐడెంటిఫై చేయమంటాడు, కన్ఫ్యూజ్ ఇస్తాడు, రెండు ఇస్తాడు, టీ నెట్వర్క్ ఇస్తాడు, పై నెట్వర్క్ ఇస్తాడు, మనం కన్ఫ్యూజన్ అయిపోతాం. సో అందుకే ఈజీగా గుర్తుపెట్టుకోవాలి. ఏ ఈక్వల్ టు డి ఈక్వల్ టు మాత్రం సేమే, 1 ప్లస్ వైజెడ్ బై 2, బట్ ఫర్ టీ నెట్వర్క్ బి ఈజ్ ఈక్వల్ టు జెడ్ ఇంటూ 1 ప్లస్ వైజెడ్ 4. ఈ 1 ప్లస్ వైజెడ్ 4 అనేది ఇక్కడ ఉంటుంది టీ నెట్వర్క్కి, ఫర్ పై నెట్వర్క్కి సి దగ్గర ఉంటుంది, అంతే తేడా. A equal to D equal to 1 plus YZ by 2. If it is a T network or pi network, those two parameters are values are same. But coming to the B and C values, for B, T network is nothing but Z into 1 plus YZ by 4. But coming to the pi network, it is Z only. 1 plus YZ 4 and the C kelp. C value for T network just Y. But coming to the pi network, Y into 1 plus YZ by 4. Right? Just small tricky values you have to easily identify, then you can answer at least 1 mark, right, for a competition exam or it may be a gate exam also. Now we have to A equal to D, it is a symmetric network and and evaluate the AD minus BC equal to 1. This is also same. That's why medium transmission line also symmetric as well as reciprocal networks. షార్ట్ ట్రాన్స్మిషన్ లైన్సే కాదు, మీడియం ట్రాన్స్మిషన్ లైన్ కూడా సిమెట్రిక్ కండిషన్ అదేవిధంగా రెసిప్రోకల్ కండిషన్ సాటిస్ఫై చేస్తున్నాయి. రైట్. జనరల్గా అయితే మనం నెట్వర్క్లో అయితే సో మ్యాట్రిక్స్ ఫామ్లో రాస్తాం. ఏబిసిడి ఈక్వల్ టు 1 + YZ/2 Z Y into 1 + YZ/4 1 + YZ/2. సో ఆ విధంగా మనం రాస్తాం. రైట్. ఓకేనా? సరేనమ్మా. ఏమైనా డౌట్స్ ఉంటే అడగండి. ఇంతతో ఈ క్లాస్ ఆపేస్తున్నాను, టైం అయిపోయింది.